again, if you have any questions, let me know. And I'm going to share my screen with you guys. And again, you know, when I say guys, I mean all you guys, not and gals, or however you. I'm an old guy. That's what I call everybody, guys. Okay. So yeah. So let's take a look at here if I got anything. Blah blah blah. Let's look at the assignments first. So I'm going to jump over to courses here. Oops. That's you guys. And lesson 10, I believe. All right. So I've got a little video here and another video here. I don't know why you're giving this to me now. Anyway, so it talks a little bit about what we're going to talk about today. You got the standard crazy joke here on a raise. Why did the programmer quit his job? Because he didn't get a raise. He might get fired from his job if he didn't get a raise. Excuse me. So we're going to read over chapter 7, hopefully. And I've got 3 programs, 2 of which I'm going to give you help with, okay? We're going to look at distinct numbers today. And this program would really be easy, except for one thing, and that's that they want us to, by that they mean, let's say that you put in 10 numbers. That's what we're supposed to do. We put in 10 numbers, and they want us to put a space in between each one, put them all in at one time, and then show the ones that are distinct. So let's say I put in 1 space 2 space 3, 1 space 1 space 2 space 3, 1 space 2 space 3, that's what, 9, and then a 4. So the distinct numbers would be 1, 2, 3, and 4. Or if I put in 7, 7, 7, 7, 7, 7, the unique number would be 7. If I put in 7, 7, 7, 6, 6, 6, 5, 5, 5, or something to that effect, then the numbers would have been 7, 6, 5. They have to be in the order that they are put in. I can't just go back and say, okay, there's a 1, there's a 2, there's a 3, there's a 4. Because if I could do that, it would be really simple. All right. So that's the first program, and that's the one we're going to look at today. The second one is to count single digits. This one is not a brain buster, believe me. So you're going to generate 100 random numbers between 0 and 9, okay? And then you're going to, as it generates those, it's going to sort or count how many zeros there are, how many ones there are, how many 2s, and 3s, 4s, how many 5s, 6s, 7s, 8s, and 9s. And then at the end, it'll say, okay, you had 10 1s, you had 5 2s. You know what I'm saying? Somebody tell me you guys are alive and still there.
Yeah.
Yeah.
All right.
Yeah.
So that's that one. The locker game, it's a bear. And I'm going to give you the code to it, basically. Or at least a video on it. And it's basically, I forget how it actually works. It's something like there's 100 students or something like that. And everybody's lockers are lined up. The first student's locker is locker 1, second student's locker 2, locker 3. And they go in, and I forget how it works, but something like student 1 goes in, and then he, however the lockers are right now, he reverses that. He opens his but then reverses everybody else's. Then number 2 goes in and opens his and reverses everybody else's or something like that. And at the end, they want to know which lockers are open and which lockers are closed. So it's like one of those games, like a riddle or something like that. I had a really hard time with it when I originally wrote it. And so I'm going to help you through it. So don't worry too much about it. We'll hopefully take a look at that on Thursday. So make sure you show up on Thursday for that. So that's the assignments this week. The idea behind arrays, I'm going to switch over and go to Excel here. All right. So this is what I did. Can you guys see that? Can you guys see this clear?
Yeah.
Yes.
All right, good. All right. So now if I asked you, I forget how many of us are here today. Let's say 15, okay, for argument's sake. And if I told you today, without using anything that you don't know, that you haven't been introduced to, I want to save everybody's name and print it out at the end of my program. How many variables would I need?
15.
15, right? Because if I just told you to print out 15 students, you could get their name printed out, get their name printed out, get their name. But I don't want you to do that. I wanted you to get their name and save it to the end of the program and then print it out. Now, my next question is how many input statements would you need, or prompts and an input to get their names?
Could you do it in just one?
No,
So
because
15.
all the variable names are different, right?
All right, just 15 then.
Yeah, you need 15. Okay. To save all 15 students. How about if you were going to print them out? How many print statements?
15.
15. So there you have 45 lines of code just for 15 students. That's not counting your menu, Okay. Now, then again, you need to, so we get that there, okay? Here's what I would have to do if I use an array. That's it. And then this right here, let me get rid of this for right now. This right here would get all 15 names. So I got 1 line of code, 2 lines of code, 3 lines of code instead of 45. This right, hang on a second. This right here would be to print out all 15 names. 2 lines of code. And I could print them all out. So it took you 45 lines of code, and for me to get them, declare them and get them and print them, it took me 6 lines of code, right? 1, 2, 3, 4, 5, 6. 6 lines of code versus 45. What if it was 500 students? How many variables you guys need? Or how long is your code? Just at a minimum, how long is your code?
1,500 lines.
1,500 lines. Guess what?
You're still to 6 lines.
I'm still at 6 lines. I changed this to 500 right here. I'm ready to go. 6 lines. 5,000, 10,000. Okay. So definitely a benefit, right?
Sounds like it for sure.
All right. So how do we differentiate? Well, here's how we declare it, first of all. This right here. So what data type is it? And arrays can be any of the data types that we've used. It can be a Boolean array. It can be an integer array. It can be a double array. It can be a string array. It can be a long array. And then we need the name of the array. And then we create a new string and how many elements we want. These are called elements, okay? And then the elements have an index number. And so if I want 5 of them, the numbering starts at 0. So if I say right here, see where it says student length? That's 5. But I don't, if I said, do this until index equals 0, I get an error. Or do this until index equals student length. Because the student length is 5, right? Do I have an index 5?
No, you just got
No.
0 before.
Because our numbering system starts at 0, the element numbers are 1 less than our total, okay, of the length. So you have to be careful when you use this for next loop here, that you never make this that student length can be equal to how many indexes we have. You guys comprehend that? It'll always be 1 less. And that's where some people, you'll get, if I did do that, I would get what's called an index out of, what is it? In other words, my index is too big and you'll get an error. Your program will error out. All right. So kind of, sort of, you understand that? It's not really complicated. And again, they're all written like this to declare them. They're all written in the same format. And again, where this number is, how many do I want? One of the things unique, or not unique, but basically, but that is a problem in Java is that arrays are static. And that means once I declare it as being, let's say in our case, 5, I can't change that. So if I was to have another kid come in or another student come in, I would have to basically rewrite the program. Or what happens in some programming language, you can change how your index is on the fly. They're dynamic. They're not static. That's the 2 different names. One is Java is static. Visual Basic is dynamic, for example. So I could, in Visual Basic, I could say, okay, every time I get a new student, change the number of elements in my array. Here, I can't do that. What we do is that we would write a new array, create a new module for expanding our array, okay? And we may want to add 10 to it. We can't, it'd be silly to add 1 at a time because it's a whole nother process. And I would have to create another whole array, move these people into that array, and then continue from there. And then get rid of this array, okay? And there's an algorithm and a method for doing that. We're not going to worry about it right now, okay? So your planning, when you're going to use arrays for right now, your planning has to allow for expansion. Likewise, you can't make it any smaller either. Let's say that I was very optimistic and I thought that I would need 30 places for Java 1 students. And let's just say we end up with 20 people in the class. I cannot cut it down without rewriting the whole, or having a process and method to do that. So it is a little older in its technology, if you want to call it that, than some of the other languages. So those are single dimension arrays. You should think of it as rows. So I have 5 rows here, because in the next couple of weeks, we're going to have a matrix of array. In other words, we can have multi-dimension arrays. All right. But before we do that, even, we're going to, and some books you'll read, and some, if you look online, they don't believe in what are called parallel arrays. Okay. So there are things called parallel arrays. And it's not really hard to think about. I can create this array here with the names of students in it, and I can create an array called grades with the same amount of elements, where I'm going to just put these, they're not really together, but if I use the same index number for both arrays, I can create things. Let's see, let me back up some more here. Well, that's silly. It went back farther than I. Okay, so now I have 2 arrays, 2 separate arrays. I created this one over here. It has 5 grades in it. And now I know in my, this is the grade for Doug gets a 70, Rob gets the 90, Jeremy is going to get an 88. So how do I input those then and associate them together? Well, I can just come down here and insert. Let's see here. And just come over here and then just type system dot out dot print, enter a grade. And then here, it'll be grade. And then based on the index, it'll store this grade. So now I added 2 lines, and now I'm getting the grades too. Just think over here again. For every student, if we needed grades, so if I had 5 students, I need 10 more or 5 more lines of code to get their grades. Or if I had 15, I'd need 15 more variables. Here, all I need to do is add these 2 lines and this declaration here, and now I can store the 5 names and I can store 5 grades. Likewise, if I come over here and just pop in this, let's see here, what will it be? It'll be a plus, and we'll put a space in. And then grades index. I think that's it. Okay, fixed. So now I'm taking in 5 names and 5 grades. The only real association between them is this index number for the elements. Okay, they're not connected in any other way. It's just I'm using that element number to produce something that looks like those grades go with those names. So that's okay. But in the couple, in either, I forget if it's next week or the week after that, we'll look at multi-dimensional arrays. And instead of doing it this way, I could do it, here's a declaration here for a multi-dimensional array, and I had 5, what did I have? 5 names with 5 grades. Okay, so there. And how many things do you think I can, how many elements can I save with this declaration?
25.
25, yeah. 5 names, or let's see, what do I got? Yeah, 5 names with 5 grades. If I wanted to reproduce this, what I have here, all I need is, well, I wouldn't have that many grades. I'd have their name and 4 grades, I guess it would be. And then here, if I do, hang on one more time. If I do 5, 0, 1, this right here would reproduce what I have here. This with 2 columns. So basically here, let me, so 5 by 2, let's see, 5 rows, 1, 2, 3, 4, 5, 2 wide. So their name would be in this column, right? And their grade would be in this column. If I had a 5 by 5, more, I would have 25, right? Because I'd have 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, or no, 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, etc. until I got down here to 5, 4. Or 4, sorry, 4, 4, because of the 0. So I'd be able to fill in all those squares with data. This, in this case, this would be their name column, and then I could put in 4 different grades for each student. So that would be a 2-dimensional array, okay? Can you go farther? Yeah, you could go farther. What does MLB stand for? It's an abbreviation for.
I mean, I would say Major League Baseball.
So would I.
Okay.
Yeah. So let's say I had a Major League Baseball team. Okay. And I don't know how many there are. I'm not that big of a. So let's just say I had 25 teams, 30 players on a team, and I want to know 10 stats about every player. How many elements is that? How many things, how much data could I save by just declaring this one line right here? Somebody that's a math student, maybe.
Is it 7,500?
It is 7,500. Yeah, I could save just by this one line, I can save 7,500 items. And I can visualize that. How many, has anybody never seen a card catalog, a physical card catalog in a library? You know what I'm talking about? It's a series of drawers like this, and then there's cards in them, right? For the 3rd dimension. So there's rows of drawers, there's columns of drawers, and then there's cards in them. Well, if you visualize that here, the rows of drawers would be the team. The column would be the player name. Each player would have their own drawer. And then inside that drawer, we would have 10 things about that player that we could enter, like their first name, last name, batting average, position they play, etc., etc., for a total of 7,500 pieces of information we declared here. How do we assign, if all I wanted to do, if I wanted to hard code instead of this, if I wanted to put my name in student 0, this is how I would do it right there. Or if I wanted to put Mary's name in here. You just say, okay, I want to put Mary is assigned to, right? We read from right to left in programming. We take Mary and assign her to student 4. We take Sue, we assign her to student 3. Okay. And that's how we do that. Over here, of course, we've automated it down here in a loop where the index changes every time we loop through it. So the first time through, student 0 is equal to Doug. What's Doug's grade? So grade 0 is 70. Loops up, and it says enter another name. What's the student 1? Well, that's Rob. What's Rob's grade? Well, it's a 90. Assign it. Then we can print all those out just as easily. Any questions about, I mean, I know it's new, but you basically see the concept? Or can I explain anything else about the concept? All right. So then my question is this. And somebody different than's been or I might ask somebody what they think. If I want to save all the months of the year, how big of an array do I want? Tori.
You would want an array that has the 30 days in it?
No, I want the months of the year. How big of an array would I want?
12?
12, right? Who agrees with her?
Yep.
Yeah,
Yeah,
I do.
Okay. So now I'm going to ask Tori another question. Tori, this is kind of personal, but what month were you born in?
July.
Which one?
July.
So that's month 7, right?
Yes.
Oh, no, not anymore. It's month 6. Who understands what I just said and why?
yeah, because you
From
start at 0.
Yeah, if you're anybody born in January,
Yeah, me. Ben.
you're a 0, dude.
Uh,
Now, does that make sense to anybody here?
Yeah.
It doesn't to me. It's confusing. So you know what I'm going to do? I'm going to create an array of 13 months. Okay. And January is going to be in month 1, February in 2, November in 11, December in 12. And you know what I'm going to do with 0? Nothing. I don't have to put anything in there if I don't want to. I'll just start my count at 1 instead of 0. If I want to put something in there, I could put NA for not applicable. I could put month, the word month in there. It don't really matter. But just because I declare it, I don't have to use it if it doesn't make sense. So my next question is, what if I was doing the days of the week? How many are you going to have, Will? Will? Will, did you check in and now you're eating breakfast somewhere? Gerwinder, what would you do?
Well, there's 7 days of the week, but I would, let's see.
Say it.
I would write as an array of 8.
There you go. That's all I'm looking for.
Oh, okay.
Yeah, because Sunday you don't want to set it, you know, set it at 0, right? Doesn't make
Yes.
sense. Okay. And I think about that with other things too. Maybe the floors in a building, which are sometimes weird because some buildings don't, they usually a building doesn't have a 13th floor, or a lot of buildings don't. If you go up in an elevator, there won't be any 13. Talk about,
Yeah, bad luck.
yeah, bad luck. Exactly.
Or in,
Also, who wants to sit in seat 0 on an airplane? I don't know where that's at. I think it's out on the wing or something. So there's instances where to do it logically, again, and I know people that do it, they'll say, well, I'll just add 1 to the count. Understand what I'm saying? Just say, okay, if it's this, it's really this. So I can run the 0 month one, and yet add 1 to whatever number I'm on to make it more realistic or more worldly, let's put it that way. So just something to keep in mind. Again, programmer friendly, user friendly. Nobody's going to know. You don't want to be trying to explain to a user that, like Tori, oh, Tori, if your birthday's in July, you really need to put in a 6 because a program, da, da, da. Your user doesn't care. They want to type in what the natural thing would be. All right. Comprende? Everybody's good?
Yep.
All right. Any questions? I'm still wondering if, who did I ask was here? I forget now. He might have went away. Don't know. All right. So let's write a program. The program I'm going to write is that distinct number thing. And like I said, if you go over in the book, you know what? Let's go back a second. Let me alter this for you so yours reads correctly. Okay, count it. This is terribly difficult. Read it carefully. Don't forget to count the distinct numbers. Count of distinct numbers. That ain't right. I want a long line change that you can input all 10 numbers without spaces. And the hint will be save as a long. All right, that looks better. Again, just because they put it in there, it's like other things that I don't expect you guys to follow. Some of these programs are going to say that you need to have certain methods. No, you create your own methods to solve the problem. You don't have to say, if the book says, well, you need a method for this, a method for this, a method for this, a method for that. No, you don't. You need to break it down into parts that you think are logical. Okay. That doesn't mean you can say, well, I think it's logical to just leave everything in the main, because no, that's not logical. All right. But you can create your own. You don't have to name them what they name them. Okay. So new program. Oh, our infamous ant here. And let's call this, what do we want? About, I can't type today either. Acme distinct. To be able to spell distinct is kind of a weird word. And so, how'd I get a? All right, so our project will be the Acme distinct number project. And this, we're getting up to where we're going to be using this in our code pretty soon. This is the Acme distinct Java file. We'll have many files coming up in the future. Today's date is the 10/20/2020, and then who am I? Yeah, have to look in the mirror in the morning to remember who I am. And the purpose, this program will get a list of 10 digits, or a 10-digit number, and produce an output of all the distinct digits. Somebody's got a mic on and playing basketball or something. Okay, so see that? Here's the 10-digit number, right? And which ones are distinct? Well, there's 1s, 2s, 3s, and a 5. So the distinct numbers that we would want to produce would be that. Does everybody comprehend that? Because distinct has different meanings. You know, when I first read this, I said, what do they mean by distinct? You know? So that was kind of, I want to solve that thinking problem there. Move that in a little bit. Do this little thing here. Bring this down. And then this will be indented too. Hang on a second. I got to yell at my wife. Something's going on in the other room. So there's our setup here. Save that. First thing I'm going to do is, again, it says that I got to get 10 digits. So I need a scanner apparently. And I like my little thing here. So then we've got void main. All right. And what did I want here? I think we'll call it char go again today. And equals to, the char is going to be Q. That's going to stop the program. Okay, and then I'm going to want a do loop. Again, a post test loop. that will eventually, we want it to loop while, go again, is not equal to capital Q, and we could even run it now, and it should just say it ran and then quit. There you go. So that's working. And so let's go here. So inside our loop, tab, we're going to have go again, because I need to be able to increment my loop. I'm going to call it show menu. So now I have a call to a method called show menu. Okay, so I need to get out of the main. Right here. And what am I returning? I'm returning a char. So it's going to be show menu. And you should have something like this about down pat, because all of your programs should have something similar to this nowadays, because you're just writing better programs, and all of our programs have some type of a menu, a declaration of.
I have a quick question.
Yeah,
What exactly is the difference between the public static and private static?
public means it can be used by other, what do I want to say? Other programs in our other classes in our package, or even outside our package. Private means this method right here can only be used inside of this class.
Okay, that makes sense.
And then there's another one, I think it's called protected. I'm thinking this is in Java, that only allows you to use them if they're a child class of a parent class. But usually you'll just see public and private. Private just means I can only use it in here. Okay, so I can call this from any other method in this program, like I'm calling it right now. I'm calling it from the main down to here, right? But I couldn't go to another class out here in my, what we're going to do in the future, and call this individual method, because it's only good, the scope of it's only good in here. Does that help?
Yep.
All right. All right. So I want to do loop inside here too, because I only want to return things that main knows what to do with. So I'm going to have 3 chars that are legal. I'm going to have an R for run. I'm going to have a T for test, and I'm going to have a Q for quit. So I want to have a do loop that handles that, okay? So eventually what I'm going to have is I'm going to create another char here, something I can save something to. And I'm just going to call it char again for no other reason than it's just a name I thought up. And then this loop will run so this will be while again is not equal to, oops, R for run, and it's not equal to T for test, and it's not equal to the Q. So if it isn't one of those, it's going to throw you right back in and they have to do it over again. Well, I should probably warn them that they did something wrong, right? So I'm going to put an if statement in here. And it's just going to say if, and then I can just copy everything I just typed down here. Control C, Control V. So if they don't do what they're supposed to do here, we're going to send them a message that says, bad boy. We'll say, oops, come on. Blah, blah, blah. Yeah. Go here, go here. What's it yelling at me? Well, it might not have been initialized. Okay. Char again is equal to Q. We'll make it. Then maybe it won't yell at us. Okay, so we got that. And finally, since this is a function, and functions do what? What's the difference between a function and a method?
It returns.
It
Function
returns
returns it.
something, right? Now, again, a function is a type of method, but it's a method that returns something. So I need to return something. In this case, I'm going to return again. So this will say return again. And then let's scroll up here and let's see if in fact it does return it. So we can go here, system checking as we go again. Making sure that whatever we do down here comes back up here, that we pass it back to the calling method.
Do we have to make our scanner?
Oh yeah, we didn't scan anything, did we? Blah, 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 blah. Yeah, we need to be able to change that. What's wrong with us? I get carried away sometimes, you know. Okay. Well, I need to show the menu too. We haven't done that. Jeez Louise. I get ahead of myself. I set up the loop and then I didn't put the code in it. System.out.print /n Acme fine, or what did I call it? Acme, put it up here. Just look at it, I didn't spell it right here and I'm yelling at you guys. Distinct. It's just a weird word. /n /t, and we'll have a run here. /n /t. /n, enter, /t, and then quit the program. /n, N/T, and then enter your menu choice. Something to that effect, I think. And now we've got our char, oh, I'm sorry, again, being equal to con in dot next parentheses 2. I thought that's what I named it. Dot.
I don't think we've declared it yet.
Oh my
Yeah.
gosh. Let's go up here. Oh my goodness. Private, static, final, and we're going to call it con in. You can tell I write these programs so many times I forget. In is equal to a new scanner of the type public static, no private static, final scanner, con in, there we go. And then we've got the system in as the argument here. Much better, much better. Now we can come down here, blah, blah, blah. There's con in. And then next, to upper. And then char at 0. Getting the first character of whatever they type in. So again, if you're writing a lot of programs, you could just copy that instead of having to type it every time. Just come and get this code, put it in Notepad or something, and type it into your, have it created in your program, and then you could tweak it. But again, by using these modules, you can set them aside and reuse them over and over and over again, right? A lot easier.
That's what I did with last week's assignments.
There you go.
Copy pasted, tweaked it.
Saves you a lot of time, right?
Yeah, a lot of time.
So let's see if this thing runs now. Jeez. Okay, so there it is. And if I type an R, it says, yep, you typed an R. If I type a T, it says I typed a T. If I type a Q, it quits. If I run it again, and I type the letter A, it says, uh-oh, only R, T, and Q are valid inputs. Type the number 1, nope, can't do that. Type a exclamation point, nope, can't do that. Hit Q, yep, works fine. So nice little set of how to start your program. Has a nice banner that goes across the top. And we know it works at that point. Okay? We know it works. All right. So now we're going to stub in. We got the input from the user. Now we need to stub in what we're going to do in each case. What if they type an R? What if they type a T? What if they type a Q? And if I'm going to make decisions like that, what are my, I have basically 2 options, right? What are they? What are the 2 options that I can do? Oops.
You could do a if else,
Yep, an if else is one.
and man, I can't remember
Switch.
the switch. Yeah.
Yep, the other one is the switch. So I'm going to put a switch right here. And again, I could, just like he said, I could do it in an else if I wanted to. But we'll use a switch because it's easy. And so my case, I'll have one case that'll be a R for run. And I'll stub it in right now, just system print line and just say run is here. Don't forget to put your break in. And then we'll put in case T. And oops. And finally, we'll get to, now I could make this this default, but I'll go ahead and make it the Q. I know in this case, I know that the user can't get to anything else except RT and Q because I have that loop down below, preventing them from doing so. So they really can't do anything but these these three characters anyway. Okay, this one's a little bit different. So we can just put that there. We don't need a break because if it comes here, it's leaving anyway. Okay. We're not going to need to print that anymore. We can rem it out, or actually we can just get rid of it. And now we're going to test that our switch works. So we'll go here, run it. And if we choose R, it says run is here. We choose T, it says T is here. If I type in A, nothing happens, except it comes right back. If I type in Q, it says thank you for using Acme products for all your computer needs. And so that seems to work good. So it looks like that. And now we've broken, see, now we've broken that down. Now we can work on the run first, then we can work on the test, and the queue already works. So we're breaking this down again into its parts. Okay, so I'm gonna, right here, I'm gonna type something, declare a variable called string, and I'm gonna call it values. And then I'm going to set values. And I don't need to send anything down because I don't have anything to send down at this point. The data type for set values is what? String, okay? So we know it's going to return something because if it isn't returning anything, it would be a void and a method. So this is going to be a string, set values. Run that cross, nice little divider. And so this will be private, static, string, set values. So this is where we're going to get the numbers. Okay. Now, again, in the thing, they're putting them in as a string. We're going to do a little tricky stuff to make our life a lot more enjoyable, let's say at the least. So I am going to declare a string here called str number or num. And I'm also going to call one a long temp. Now, long is just an integer that has over 2 billion as a value. It'll hold numbers more than 2 billion. And for a 10-digit number, I think that's over 10 billion, or maybe not. I'm sorry, over 2 billion. It could be. All right. So then I need a do loop. I use a lot of do loops. And I'm going to say system dot out dot print, enter a 10-digit number. Simple as that. And then we'll do a while, not con in dot has next long, like that. Enter. So this is where I'm checking to see if in fact they type in 10 digits, right? Because the only way to get a 10-digit long number is that it has all, so I'm getting rid of any chance of them typing in any letters, punctuation, decimal points, anything like that. So this is the easiest way I know of to check that without changing everything into a character and blah, blah, blah. And it works so much easier than putting in spaces and all that kind of junk. So that's why I'm showing it to you this way versus what the book was trying to have you do. This is con in, clear the next, do that. And the other problem with doing that with the spaces is you have to use the next line command, which I absolutely, it always has problems. Let's put it that way. Or I think it does anyway. And so once it checks it and it's right, then we can save it as temp is equal to con in next long. Geez, excuse me, you guys.
Bless you.
And then we're going to say string number because we need to change it back into a string, and I'll tell you why here in a second, is equal to string dot value of temp. So now I changed the number into a string. Why? Because I want to count how many characters are in it. And I can't do that if it's a number. Okay? Because I'm going to beat them up down here with my do loop if, in fact, the length of string num length, it's the one that has the parentheses, is not equal to 10. Because I know I'm supposed to have a 10-digit number. It can't be less than, it can't be more than, it has to be equal to it. So while it's not equal to 10, I want to keep them in the loop. Once I have that, I'm going to send back, well, what did it call for? What am I supposed to send back? I'm supposed to send back a string. So that's what I'm going to return. So I am going to return the string num. And I can come back up. I'll let you look at that for a second if you were typing. I'm sorry. Geez, it's already 10:42. Oh my goodness. Oh, well, maybe we can. How about trying to look here? You guys want to go a couple extra minutes and we can get the other part of this in, and then on Thursday we can tweak it a little bit, or you can tweak it on your own, really. Can you give me
Yeah.
5 more minutes?
Of
Yeah, that's fine.
course.
Yeah.
All right. So now we're going to return that up to the top here, and we want to make sure that we get them back. Okay. So we're going to try our string system.out.print line, and we want to print the values and see if in fact it returns 10 numbers, 10 digits. Okay, so I type R for run and enter a 10-digit number. I type in 1, 2, 3. It says, nope, can't do that. ABC, nope, can't do that. So now I'll do 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And it does it and brings it back up. Okay. It won't do 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Nope, that's not good. Whoops, I did that for the menu. Run 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Says you can't do that. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And that works fine. So then I hit quit. We're out of there. All right. So now we know that works. Okay. All right. Let me go back up to the top again. And we're actually going to do a void. We're not going to return anything because I'm going to say here that we're just going to call and say set distincts, and just we need to send the values that we just created to it. Okay. So we're sending it down there. We don't expect to get anything back. I could, if I wanted to have a separate print statement, okay, but in this case, I'm not going to. I'm going to say just do this. And this is private, static, void, set distincts. And, oh, let's just call it string digits. Again, I'm sending something down, so I have to have something here to catch it. Sending an argument here, so I have to have a parameter that will accept what I'm sending in the right data type. All right, and so the real processing of it is we're going to create an array. We'll call it int nums. Int nums, and it's a new array of ints, and we'll just say that there's 10 of them. And then I'm going to say int value starts at 0. And then I'll declare an int index here also. And I'm going to have a for loop where it says index starts at 0. And the index will be less than the digit. Hang on 1 second. I think I might have had an error here. No. Digit length. And index plus plus. All right. And inside our loop here, we're going to say value is going to be, what did I make it? Equal to a character dot get the numeric value of what's in digits char at the index number. So basically we're going to go get a character out of our string. So like the first time through, it'll get the first character, the 0 character, then it'll change it into a number. Okay, and give it a value or save it as value. And then what do I want to do here? Then we'll say nums, and that's an array, right? And then the value that we just got, we're going to say that there is one of those available. So we put the number 1 in that array. So like, let's say the first number in our string is 6. So then we're going to get the number 6 here, and in array element 6, we're going to put a 1 in there. Okay, in array element 6, which would actually be the 7th element. Then, to display them in the right order is just a little trick I made up. If nums value is equal to 1, then we want to print it out, what the index is, what the value is. Okay? And we only want to do that once, right? Because they have to be in order. Okay. And they're distinct, so we can only need to print them out once. So then I'm going to just say system.out.print and value. Da, 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 da. And those should all be good down below. And now if we run it, all right, so I'm going to put in 5, 4, 3, 2, 1, 1, 2, 3, 4, 5. Whoops, that wasn't what I was supposed to put in. R first. Okay, 5, 4, 3, 2, 1, 1, 2, 3, 4, 5 are my 10. And you'll see it put them in the right order. The 5 was the first one, second one, third one, fourth one, fifth one, and it did not repeat because these are not distinct. Okay, I'll run it again. And I'll say 6, 4, 2, 1, 3, 5, 6, 4, 2, 7. And you can see I got my 6, 4, 2, 1, 3, 5, and a 7. I didn't get the second 6, the second 4, the second 2. So the program works, okay? Now, that leaves you guys to do the test. Oh my gosh, that's going to be terrible. You're going to copy this, and in string values here, you're just going to hard code in a random, you can do a random number, or you can just hard code in, and you put it in here, you paste it, your program's done. You mean this, Doug? You're just going to go ahead and take this and go Control C, come down here, put in Control V, and you could just type in right here, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1. Let's say. Now, what I will say is it'd be nice to see those. So you might want to go ahead and system.out.print line values. And I run it. Hopefully this will work. Type in a T, and there's my numbers. Now again, let's try and put some labels in that said, here's the distinct numbers of this, if you know what I mean. The other way to do this, you come up here, import java.utility.random. I think this will work anyway. Come here. Ah, la 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 la. Random dot RDM is equal to a new random, and then string values is equal to RDM dot next. Or is it? Oh no, it's just an. Ooh, how am I going to do that? Next. Long, and then it'll be what? 99. No, it won't. It'll be backspace, 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 10, 3, 4, 5, 6, 7, 8, 9, 10, 11. That. This will be an L. And I know it's going to yell right now. So I'm going to type long here. Still don't like that, does it? Well, of course, something has to go wrong, right? Next, long. Can I take that out? No. Is that too big? I don't think so. Well, maybe we'll stick with the first one, huh? That should work, though, I believe, unless I type something wrong. Let's just. What am I missing here? Class random cannot be applied to given types. Required, no. Found an int. Let's try this. No, don't like that either. Huh. I'm doing something stupid here. Reason formal arguments listed differ in length. Okay. So what am I missing here? Well, something's goofy. So instead of dragging this out, we'll just do this and light this back up. If you can figure that out, it'd be great. There's just something I've got going here that is not kosher. And that likely, it's kind of how my days have been going the last 2 days. But you do have a program that runs. It also does the test, and it does quit. Okay? So I'm going to stop sharing. And I will see you guys on Thursday. Probably just provide you the locker code. We'll probably have a lab day. But maybe we'll go through it. So come around. We'll see what happens, okay?
Thank you, sir.
Okay.
Sounds good. Thank
Thank
you.
you,
Have a
sir.
good one,
Thank you.
guys,
Thank you.
ladies.
Thank you for your time.
You're welcome.
Thank you, Professor.
Have a great day. Will, you there or not here?